All right, this lesson is going to be lathe lesson 7. This is going to be the exercise this time around. Okay, so I'm just going to get started since I kind of went over in the last one in the tutorial how to do a lot of the stuff. I'm just going to start going through this, and as we go, these videos will start speeding up just because I don't need to review the past video as much. As you're doing them, you should be getting used to this, and I shouldn't have any issues. All right, so the first thing I'm going to do, of course, is I'm going to start with lathe, and I'm going to pick my the correct post here, and I'm going to go down to my planes, select my DZ plane, hit equals, and I am ready to start drawing. Okay, so it looks like the first place that I'm going to draw is going to be at a 3/4 inch diameter, so I'm going to start at 0.75 comma 0. And I'm going to go to 1.0 comma 0. Oh, forgot to hit my multi-line. Turn that on, makes things a little bit easier. Then I'm going to go to 1.0 comma negative. Looks like 1.075. Yeah, 1.075. 1.075. By the way, something you can do here is you can actually write an equation in here that kind of leads me to that. So if I said negative, in this case, I'll just say negative, and then I can put in parentheses 1.45 minus 0.375, and then end parenthesis and hit enter, and it will draw my line for me. So I can put an equation in here, and it will do that. So if you ever run to a place where you have some weird math, I mean, I obviously can do that in my head, but if you run into one where the numbers are really odd, and maybe it's a few digits, you can just write an equation in there, and that makes things a little bit easier for you. Next up, I'm going to be going to... Oh, and by the way, once you do it, you can actually see where you're at in the Z down here. So it'll actually tell me where my cursor's at. So if I do a perpendicular line, I can see there that my negative 1.075 was correct. So I can go to 1.425 comma negative 1.075, and then I'm going to go to it looks like 1.425 comma, and then I'm going to go to negative 1.45. Enter. All right. So I usually end it right here. Since I have a chamfer there, I'm going to need to put this line. So I'm just going to say it's going to be 0.75 comma negative 1.45. Enter. And I'll just connect this thing. I did need to connect it because I needed to do this internal bore anyway, so that's really the profile that I do need. But if I was just doing a straight profile and I'm not going to chamfer the backside, or if I'm going to chamfer it and I'm going to utilize the cutoff to chamfer it, I don't need to actually put a chamfer on the actual geometry. So it looks like this chamfer is 0.625. 0.0625. Oops, helps if I click in there first. And click. Okay. All right. That looks good. And it looks like we got to put some 50 thousandths radii in there, 0.05. I need one internal, one external. Oops. There we go. All right. So it looks like that part is drawn pretty well. The only other thing that I got to do is I got to put in my milling slot depth here. And that is 0.0625 in depth. So I can actually just connect these here. And that's going to be the same depth. So that's perfectly fine. And it looks like that's it. I think that's all I need to do for my drawing. All right, so first thing I'm going to do, obviously I need to set my stock up. So when I change my stock plane, of course, that needs to be DZ. And my properties, this is going to be, let's make it at a 2 inch. Why not? Length is going to be 1.425. And turn my margins on. I'm going to give myself an extra 2.0 to hold on to. My right margin, I'm just going to give myself 10 thousandths to face off. And I'm going to hit check. And I'm not going to worry about my chuck jaws. You obviously can set them up if you'd like. It really is up to you. I'm going to do it actually just to kind of show you with a different part here that's a little bigger. In this case, we're just going to go to parameters. Obviously, this has changed a little bit since the last version. Yours probably will be the same. I don't think I'm going to update these. But if you do download 2021 on your laptop or your home computer, then this will apply. So diameter is obviously going to be 2 inches, 2.0, and the Z, this is 1.45 long. It is from 0, is where it's taking this Z, the front of the jaws. So I'm going to say I want this to be negative 2.0. We're going to see if this works. I can always move these back further. I think that should be fine, though, so we'll see how it goes. All right, so I'm going to hit check. And we may have to move them back. We might not. We'll see. Okay, so next thing I'm going to do is go to my, not milling, turning. I'm going to face this. And, of course, I'm going to use this 80 degree. Make sure my spindle speed is correct. And my max speed would definitely never be this high. My max spindle speed would probably be like, I'd probably keep it at 3,000 or maybe even 2,500. Doesn't need to go that fast. My constant surface speed, I'd make sure that's correct as well. I'm not going to take the time to set these correctly, but obviously for your tutorials and your lessons that you hand in, your homeworks, I'm going to want those to be correct. You're going to want those to be the correct speeds and feeds. Constant surface speed 200. That is probably a little low. So we'd probably pump that up a little bit. All right, all this stuff looks good. We're fine there. And there it faces it. Okay, so let's do the rough. Actually, I'm going to do this in a little different. I'm going to drill this first. So I'm going to pretend, again, that obviously, if I'm using a high-speed steel drill, I'm going to want to spot drill this first and then use my high-speed steel drill and drill it out. If I'm using a big heavy-duty carbide drill or an insert drill or something like that, then generally we don't spot drill. Not generally, we almost never spot drill for carbide drills or insert drills or spade drills. You just plow them right into the material. So we're going to assume that I'm doing that. So I'm going to go into my tool library again. I need to go down and select my drills library. And this is 3/4 inch diameter, so I'm going to look for like a 5/8 drill, maybe something a little bit bigger. Where was I at there? 9/16, 9/16, 5/8. Let's do 11/16 and hit check. And order depth, we're just going to set that to there. And I'm going to take my compensation. And we're going to break through. Let's go an extra 50 thousandths. I'm going to want these all absolute, by the way. And it's drilling an inch and basically 1.45. There is a rule of thumb for pecking. We'll go over that when we go over drill cycles in CNC. So right now, that should be fine because it's only 3 times diameter, so that is okay. So we hit check. All right, and there's our drill. Next, let's rough this inside. Hit check. We're definitely not going to use that tool. So we're going to go in, go back to our other. I wish they would just put, we can create a library where we can have all these in one, which is kind of handy, but it also kind of really clutters the library as well. So I'm going to use a 1/2 inch just because when it says a 1/2 inch bar, that's the size of the bar, not the size of the bar, the back side of this bar over the tip of the insert. It's actually more like 5/8 total. So we're going to pick this 1/2 inch bar. And remember, you always want to use the biggest diameter and the shortest bar you can for rigidity purposes. Since we're boring and we're using a 1/2 inch bar, I'm going to turn this down to, I'm going to set this at 50 thousandths rather than 100 thousandths step over or depth of cut. Everything here looks good. Plunge parameters, I don't need the plunge, so I'm okay there. Lead in, I'm not going to shorten or extend my lead in. My lead out, the end of my contour, I'm going to extend that just a little bit. I'm going to extend that maybe 0.05, something like that. And we can kind of feather this in as we go here once we see what it looks like. This looks like it's okay. We'll see how it goes. We'll see if we actually contact the stock when it rapids out. We can also change the length of this as well. So we can make this exit vector maybe just 0.05 instead of 0.1. Let me leave it at 0.1 just to see if it contacts, just so you can see the error that it's created. We also want our stock recognition on. I definitely need to set up my operation defaults on here because I clearly have not done that with this new version. They must not have carried over. I did migrate them, but they clearly didn't carry over for this one. Actually, I'm not totally sure I've ever set them here in my office, so I'll probably make a video showing how to do that. Okay, so we're going to use stock outer boundary. Hit check. And you can see there, it's cutting good. We're not running into a deeper cut than we need to, so everything looks pretty good there. It's not hitting the backside. I want to show you what it means, what I mean by it coming out and hitting the backside. Whoops, wrong one. So let's take a look, and let's make this lead out. Oh, no, that would be why. I'm going to make it 0.2 just to see if I can get it to hit. Probably would have hit with 0.1, but we'll see. Okay, see, so right there, it's showing us exactly what's happening there. So it's coming in, it's cutting. This is where it's just starting to pull away. This is its final location. And you can see this is showing the backside of the boring bar. It's actually gouging into the part, and that's a disaster. That is a really bad crash because you're going to completely trash this bar. Bar's not going to be usable anymore. Obviously, the part's going to be completely scrapped. So this is a bad situation, and when you get these warnings, something's wrong. Do not proceed until you get this fixed. So that's the problem right there, and it's showing actually what it's taking out. So it's taking out quite a bit with the backside. There's no cutting edge on there, so it's just going to rub that away. So what we want to do is shorten this guy. And I don't know if 100 thousandths would have worked or not. If it did, it would be really close. Let's give it a go and see what happens here. 0.1. I thought I put that in, but I actually put 0.01 in, which was okay. So this does actually work. It doesn't hit. Might be a little too close for comfort for me. I would prefer, clearance is clearance. If it clears, it should clear. The only thing with that is when you're boring, sometimes there'll be chips inside of the hole because the chips don't always come all the way out. Sometimes the coolant doesn't shoot in there and get them all out. In the ideal world, yes, that would be the case. But if there's chips in there, there's a good chance that thing could have chips behind it and the boring bar could still rub. It would at least scrap the part. It might put some ugly finishes on your boring bar. So it's something you want to try to give yourself a little bit more space there. So let's go into lead out and let's change that and make it 0.0. I'm just gonna make it like 20 thousandths because clearance up here will be fine because you're at least it's just the cutting edge. Kind of show you what I mean there. 0.2, check, and regen that. What I mean by that is just the cutting edges. See the space that's here from the outline. If there's some chips here, there's already this space from this tip of this. You still have a ton of space in here where the chips can get past. Back here, it's just flat. So that is very problematic. So you definitely want to kind of err more towards keeping it closer to this side than this side. So let's go ahead and change that for the 5th time. And actually, I'm going to leave it this way this time. 0.2, hit check. Use stock as outer boundary. Everything looks good there. And regenerate and play. One of the things I think I might... Oh, sorry, I never did the finish pass. I was still going, I was like, wait a second, that should be the finish. It should line up. One of the other things that I wanted to talk about on this finish, let's go ahead and run a finish pass here. I accidentally clicked on routing. Finish. Select my... The other thing I could do here, if I hit escape, if I hit finish, I could also hit my last selection, as long as that was my last selection. Depends on how easy it is. If I have to do a bunch of chaining, then that's usually what I do. Sometimes I just click the line. I'm not very consistent on either which one I pick. One of the things I wanted to talk about was cutter compensation. So I'm going to pick this and I'm going to say I want wear on. And basically that's going to automatically compensate for whatever the tool nose radius is. And then I can also control it in the control as well. So I can put additional wear in. For the mill, I like to use wear. For the lathe, I do not. I like to use control. So then I just put my tool nose radius in the control. One of the main reasons is I like to just select tools in here. I don't have to worry about what the tool nose radius is on them because that directly correlates with where it puts these cutter paths relative to what it machines out on the shop floor. If I put control in, I can pull an insert out of the pack, type it in my control, I'm good to go. I know it's going to line up. So I always like to use control for these. Now, is cutter comp going to be a big deal here? No, it's really not because it's just going in one direction. It's moving in one axis. Where cutter comp matters is on these angles, these radii, when you're moving in two axes at once. Okay, so I'm going to go ahead and hit check and regenerate that. All right, so you can see here, one thing I didn't do was add a little bit of extension. It only went to the tip of that. So here, it did matter a little bit. If I left that on computer, it would go past. So something to keep in mind is that if you are using cutter compensation and you have it on, in this case, control, it will not show it on here compensating. It's only going to compensate in the control, on the machine. So it may look like that. So if I hit computer on here, and I'll demonstrate this on the outside because it's going to be more obvious. Oh, it still didn't do it here. So it still doesn't show it on the end. So really what we need to do is lead out and extend this. So we're going to extend this our 0.05. I think that's what we did for the rough. And regenerate that. Okay. So you can see there we're cutting in a little farther than we want to. So let's back that out. I forget what I did on the rough, but let's just make this like 20 thousandths extra. And I'm also going to put this on control as well. Where was I at there? Yeah, forgot to do it. Okay, lead in, lead out. Lead out. Let's make this 0.02 and hit check. And let's regen that. Okay, so there we're going past. That looks good. So these are the kind of things that you need to pay attention to, just to see where your tool's ending here, because we don't want to have a little flange hanging off of there. If it doesn't go far enough, that tool nose radius will leave a flange after it cuts it off. Okay, so next let's rough the outside and finish the outside. So let's do rough, and for this I'm going to pick this radius and I'm going to finish with it's asking where it wants to go. There we go. So what you saw there was it got to this intersection point, called a branch point, and it didn't know which way it wanted me to go. Did it want to go this way and up to here, or did it want to go this way and up to here? So I just had to click which line I wanted it to follow to get to this endpoint. So I'm going to hit check all the way up, turning. Depth of cut, we can do 100 thou now, 0.1. I'm going to turn, I'm going to leave my, actually put my control on, and I'll show you what it looks like, and then I'll go back and I'll turn it to computer, and you'll be able to see the difference. So this one will be pretty obvious how it works. Actually, it might not because we're in a roughing path. So I might have to do it differently. So let me actually change it. Let me put this on. Let me put this on computer. And we'll go lead in, lead out. All right, so we're gonna take this. We're gonna take this, extend it, maybe 0.225, and this looks good. And hit check. Use stock for outer boundaries, good. We don't need to plunge anything here, and I'm gonna hit check. Okay, so that looks pretty good. And you can see it left material on. You see the gray line compared to the red line. It has material on all the way around. All right, so next what we're going to do is we're going to go ahead and finish this. I'm going to do my two finishes again. So I'm going to pick finish, and I'm going to pick here, and I'm going to pick here. Of course, it's going to want to know which way. Check. And again, I need to use this 35-degree diamond so that I have clearance on the back side of this chamfer. So I'm going to pick that, and I'm going to make two finish passes for the same reason we did on the tutorial, just because it's going to plunge in here, and we're not going to leave any stock on the X. Finish step over 0.005, and lead in. We don't need anything on the lead in, but the lead out, we're going to extend this just 10 thousandths. And I'm going to come straight out and hit check. Plunge parameters, I'm going to use both X and Y. And I'm going to put this on control and hit check. And okay, so you can see with it on control, it actually shows us cutting into the stock. Into the stock. Why it's doing that is because it's using the center of the cutter. Here you can see it's off a little bit, and that's just showing where the center of the tool nose radius is at. So let me go back in and let me make this on computer, and let's regen that. And see, now it's perfect. It's going to be perfect. So what we would get if we put this in our machine and we neglected to put in the tool nose radius for this tool number, it would work out with that cutting off in certain directions. So it would be actually shifted if we forgot to put the tool nose radius in the control. But if you pick the right tool in here with the same tool nose radius as what you're going to use in the machine, you can leave this on computer. So you can simulate it like that. But I always prefer to do control because I like doing it out at the control. The other thing is, if I'm getting maybe a little bit of chatter on the part and I want to change to a 15 thousandths radius rather than a 32 thousandths radius, especially for this, the finish pass, I can just do that. I can pop the insert in and I can just change it in the control, and away I go. Here, I would actually have to come back in, repost it if I had it on computer, and then rerun it again. Either that or I could put it on wear and then type in the difference, but it's easier just to put it on control, and then just basically see and know that these lines. What I'll do sometimes, if I'm not sure this is right, I'll put it on computer just to make sure that it all lines up correctly, and then once I see that it lines up correctly, I'll change it back over to control and post my code. Okay, so this all looks good. For that, just for the sake of visualization, I am going to put it on computer, just so I can see the simulation looks good. And then, like I said, I'd go back and put them on control. Okay, so two last things we need to do here. We need to put these slots in, and then we need to cut it off. Okay, so for putting the slots in, it's just going to be the same as it was last time. We're going to pick a cross contour, and we're going to pick that one. It said it reached a branch point. The reason why is because I've actually selected chain. I could hit E for end. Now it's saying look for chain 2 or start next chain. If I hit enter, I'm good to go. It's just going to select that chain. So if you, no, I don't want to save it. Where's that? So if you mistakenly do that, if you click this and it's asking you where you want to go, you can just hit end and it'll just select that single. The other thing I could do is just select single here and then it's good to go. It's asking for chain 2 already. So I just hit enter or check and I'm good. So I'm going to go into tool and look through my library, get my 1/4 inch end mill because I believe this is a 1/4 inch wide, and it is. Spindle speed, I think our max in these things is 3,000, I believe. Feed rate is, let's just go with like 12, see what the feed ship per tooth is. 1,000 per tooth. I mean, this is aluminum, so we can easily get away with that. It is live tooling, much less rigid than a milling machine, so don't confuse the two. We definitely don't want to push it much further than this. This is about as hard as I want to push it, at least to start out. I can always add to it later on once I see how it cuts. It's just a combination of factors. There's a lot of gears and stuff that mesh inside of the live tooling head. Also, there's a castellated connection between the live tooling head and the turret that drives the live tooling head, and there's always a little bit of slop in there, especially if it's one of these VDIs. That's what I'm describing, a VDI head, which is what we have in our ST10s. If you're using the newer style, they're a little bit better, so you might not have as much problem. I'll be able to push them a little bit harder. Okay, so next thing, compensation. We want to do a centerline cut, so we don't want to compensate any direction. We're going to do a 2D contour. Everything in here looks good. No depth cuts. Lead in. We are going to turn this on like we did for the last one. We're not going to use our entry and exit motion, but we are going to adjust our contours. So I'm just going to extend this. To lead in, I'm going to extend 60% of the cutter. Because right now it's going to plunge it's going to plunge the center of the cutter right here at 0. So I want to be off about an extra 10% so that it just plunges into air. And then for this one here, I'm going to extend it past just maybe 5-10%. I'll say 10, see how that looks. That's only 25 thousandths past, just so it gets the center of my cutter through the whole thing. That way, it should work out without doing it, but I like to make sure it goes through. And I get that full width, that 1/4 inch width, the whole length that it's supposed to be. Breakthrough, no multi-pass. Linking parameters. For this here, we're going to leave this all in incremental. I generally use incremental again whenever doing live tooling. Depth. This is going to be incremental because remember, incremental is where the geometry is. So 0 from incremental is going to be exactly where I want it to be. Incremental, top of stock. So this I'm probably going to want to be somewhere around looks like I'll make this 0.1. 0.625 would be actually 0.0625. I couldn't find the number on here. 0.0625 is the top. Incremental from their feed plane, that looks good. Retract and clearance, they all look good because they're all above and they're all incremental from there. So that looks good. And then something I haven't been really doing, but you also probably want to put your coolant on. And we're going to hit it on, and we can say before, that's fine. You have to check where your post puts it for these. Depending on where your post has this inserted, whether before, with, or after, really, you just choose a post, select one, post the code, see where it's turning it on, make note of that so you know where it's at. Go back, change it, post the code, see where it's at for, in this case, with, and then do the same thing with after and just see where the differences are. That totally has to do with where your post and how your post is written. So this will not be consistent for all posts or all machines. So you got to make sure it's putting on the right place. If you have after or with, maybe you have with, it might not turn it on quick enough and you might burn up cutters quicker. So you might want to use before, or you might want to edit your post so that it turns on a little bit earlier. So just something to keep your eyes on. Hit check, and we're going to regenerate this, and everything there looks pretty good, I think. Let's run that and see how it looks. Do our first simulation. Okay, maximize. Okay, so that looks good. We're not cutting into this wall here. It's going all the way through, starting off the part. That is perfect. That's exactly what I want. So the next thing we need to do, we just need to revolve that around or transform it. So it's going to go to toolpath transform. I am going to go down and select C-axis and hit rotate. It's going to ask me if I want to unselect it. I do not want to unselect. Oh, so I accidentally hit yes. I didn't want to unselect it, but I hit it anyway. Okay, so I got the right one selected. I hit rotate. You want to make sure that you only have the ones that you want selected. Make sure that all of these aren't selected. You're going to end up with a disaster full of toolpaths everywhere. It probably won't let you do some of these, so it'll probably alarm out and give you an error. But it's just better to have the right one selected from the start. Go to rotate. It's going to ask me again, unselect, and no, I do not want to unselect it. How many instances? Remember, it's other than your first instance. So in this case, I need 3 total. I already have 1, so I only want 2. So I want 2 total, and they are going to be at 120 degrees between them. And let's hit rotate. Oh, actually, 120 as well. And then we're going to go hit from the right, check, check, and there we go. So one of the things I did there, I probably should have talked about that. No. This one here, see how this is a red line and then it's showing an angle? That is saying how far is your first one, how far is this relative to your first one? Well, it's 120 degrees from this one. And this is saying how far between the next ones, all the rest. And that, of course, obviously is another 120 degrees. Okay, so that looks good. And let's go ahead and cut this thing off. All right, so I'm going to go to cutoff, boundary point. Just going to make it here. Of course, I'm going to use the right-handed tool for the same reasons I described in the previous lesson. From stock. Everything here. I don't need to turn this on. I already did my chamfer. Lead in, lead out's okay. Cutter compensation, I don't even need this on because it's only moving in one axis. So I can just leave that on computer anyway. And you can see there, it's coming down and it's cutting it off. Now, in the case of me making multiple of these parts, I may want to bring this down so that it cuts off all of this. Then when I go and do my next face, and I'm taking 10,000ths off of this shortest part, it's not taking a huge cut right here to get rid of that little portion. So I may bring that down a little bit further. So if I say X tangent point, I'm just going to look at where I'm at and say, let's go to about here. And hit check, generate, and you can see now it's just going down past here. It's cutting everything flush. Now I can take 10,000. It's going to get a little heavier right here, but that's okay. I'm not worried about that. And that's it. I think we are good. So let's go ahead and simulate that. Okay, so only one thing I need to do there, and I forgot to do, and that is to change my stock setup, and I want to keep both pieces. Hit check, check. All right, everything looks good there. I don't see any red, no crashes. You also see red down here if it crashes. Everything there looks really good. It's all, if I hit top, you can see, now that's just graphics right there, nothing to worry about. basically this all lines up with everything. And this is just because that's where this cutout is taking place. So if I were to rotate this a little bit, you can see that the chamfer is still just fine. So if you have any questions, hopefully that covers everything. But if you have any questions, you can either see me in class or my office hours.